All right, so we're going to look at how the elements are organized to make the periodic table. So in a video store, movies are in categories such as action or comedy. When scientists organized the elements, they had to decide what categories to use and where to place each element. An organized table of the elements is one of the most useful tools in chemistry. The search for order. Until 1750, scientists had identified only 17 elements, mainly metals such as copper and iron. As the number of known elements grew, so did the need to organize them into groups based on their properties. In 1789, Antoine Lavoisier grouped the known elements into categories he called metals, nonmetals, gases, and earths. For the next 80 years, scientists looked for different ways to classify the elements, but no system worked for all the known elements. How did Mendeleev organize the elements in his periodic table? Mendeleev arranged the elements into rows in order of increasing mass so that elements with similar properties were in the same column. Mendeleev's proposal. In the 1860s, Dmitri Mendeleev developed an approach for organizing the elements while playing the card game Solitaire. In this game, the player sorts a deck of cards by suit and value. Mendeleev's deck of cards of the elements, listing an element's name, mass, and properties on each card. When Mendeleev lined up the cards in order of increasing mass, a pattern emerged. The key was to break the elements into rows. The final arrangement was similar to a winning arrangement in solitaire, except that the columns were organized by properties instead of suits. Within a column, the mass is increased from top to bottom. Mendeleev's chart was a periodic table. A periodic table is an arrangement of elements in columns based on a set of properties that repeat from row to row. Mendeleev's prediction. At the time Mendeleev made his table, many elements had not yet been discovered. When he placed the elements where their properties fit, there were several gaps in the table. Mendeleev was able to offer the best explanation for how the properties of an element were related to its location in his table. Mendeleev was confident that the gaps in his table would be filled by new elements. He used the properties of elements located near the blank spaces in his table to predict properties for undiscovered elements. Some scientists didn't accept those predictions. Others used the predictions to help in their search for these undiscovered elements. What evidence helped verify the usefulness of Mendeleev's table? The close match between Mendeleev's predictions and the actual properties of new elements showed how useful his periodic table could be. Mendeleev named missing elements after elements in the same group. He gave the name Eka aluminum to the missing element one space below aluminum in the table. Mendeleev predicted that Eka aluminum would be a soft metal, have a low melting point, and have a density of 5.9 grams per cubic centimeter. In 1875, a French chemist discovered a new element. He named the element gallium in honor of France. The Latin name for France is Gallia. Gallium is a soft metal, has a melting point of 29.7 degrees Celsius, and has a density of 5.91 grams per cubic centimeter. Heat from a person's hand can melt gallium. In some traffic signals, there are tiny light diodes, LEDs, that contain a compound of gallium. Scientists used the periodic table to explain the chemical behavior of different groups of elements. The properties of gallium are remarkably similar to the predicted properties of Eka aluminum. Scientists concluded that gallium and Eka aluminum are the same element. The discovery of scandium in 1879 and the discovery of germanium in 1886 provided more evidence.